So let's see, these are the rock ID sheets, which vaguely correspond to what we have in the box here. Yeah, sure. So usually with the rocks and minerals lesson, this is one that we do both in like classroom visits and at science nights, which are really, really different sort of settings. So in a classroom visit, you have time to introduce yourself, what you do, what geology is, why it's important to be able to identify rocks, and then you can talk through the rock cycle and talk about the different, igneous, metamorphic, sedimentary rocks, and talk about the characteristics of each one. And usually I will just like hand around a couple examples of each, and the kids will have like 1,000 questions about every rock. So you can get through like 8 rocks will take almost an hour sometimes to get around like a class of 25 kids. So that's a really nice setting because you can get a lot of information across, and you can motivate it better. And then if you have time, what I usually do is break them up into groups, and we have these little rock kits. And so once they've learned, this is an igneous rock because it has interlocking crystals, and once they've all looked at examples of each one, then I'll give them a little rock kit which has 5 or 6 different small samples in it, and I'll usually have them try to organize them as igneous, metamorphic, sedimentary. Usually have them draw one of them and describe it in detail, and then I'll go around to each group and have them convince me that they did it correct, and then I'll correct them. In a science night, it's a whole different deal because it's just chaos, and you're standing at a table with your array of rocks and minerals, and kids just run up and just start asking questions about everything. So yeah, we've got a whole array of rocks here. A good thing to do is go through and make sure that you're only presenting on rocks that you can at least identify. I usually leave 1 or 2 in the box, like a lot of the fine-grained sedimentary stuff that just like doesn't always appeal to everybody, and I can't always identify everything. But so for instance, I'll say, I'll ask them what this is, and most of the time they'll be able to identify petrified wood, and then I'll say, okay, does anybody know like how petrified wood is made? Have them come up with an explanation, sort of guide them through it. Or they really like obsidian because they all play Minecraft, and obsidian is apparently in Minecraft, it's like the strongest material known to man. And another part of the activity is our bag O hand lenses. So you can have them you can find one of the maybe more fine-grained rocks, none of which are very apparent here, and have them, maybe if they're drawing a rock, you can have them make pick a little section, say of this guy, and blow it up and have them draw that and look at finer detail of the crystals and what they're seeing there. So it's kind of a more fluid exercise that just based on whatever situation you're in, and your experience with rocks, since most of us aren't like hard rock geologists. But we've got a nice array of things, and I know Zach has contributed a few. I know this was his piece of petrified wood. There's a few more in here, so if you have like rock samples sitting around on your desks that you want to get rid of, we can take those. But we've got like native copper, we've got some bed forms, some malachite, I think. And we have obviously an example of igneous, metamorphic, and sedimentary rocks in here. And you can take the time to explain, what happens during the rock cycle, how rocks are either brought to depth and metamorphosed, or eroded on the surface and redeposited. yeah, different processes on Earth or in Earth that we can actually observe in a rock, and that sort of makes it more exciting to them than just, well, they think rocks are pretty cool for the most part, but yeah, and yeah, this is an activity